Okay, this is Mr. Long, and I'm here with my very first teaching video. So this first video is going to be on Lewis structures, which show how electrons are shared between atoms in covalent bonds. So, and this bonding mainly occurs between main group elements of what we're going to deal with. They're going to go by the octet rule. And I think you guys remember what the octet rule is. Most atoms want to have 8 electrons surrounding it, which makes it stable. And hydrogen only wants to have 2 electrons. So it's a little bit different. It's small. It's got 1 energy sublevel. So it only needs 2 electrons to be satisfied. Now the rules are that we're going to list the atoms that are in the molecule and add up how many electrons they each have. Number 2, we're going to give all atoms 8 electrons, but hydrogen only 2. That makes them stable. And keep in mind that carbon loves the middle and can only be on the carbon loves the middle, and hydrogen can only be on the outside. Electrons want to be in pairs. So let's see how this goes. So our first pack of Lewis structures will be ones with single bonds. Okay, let's take chlorine gas for instance. So we'll take Cl2. Now what we want to do is look on the periodic table and look at how many outer electrons they have. Electrons in the outer energy level. So if it's in group 17, so we know that chlorine is going to have 7 valence electrons each times these 2 atoms here makes 14 electrons for chlorine. Now when we have just 2 atoms, we're going to place them side by side because that's the only way they can be placed. And we're going to try to give them 8 electrons each and see how it works out. And they will be sharing electrons. So we don't know how this goes yet, but we know we got 14 electrons. So we're going to put 8 electrons on each one, because that's what they want. We don't know if it works out, but we know that's what they want. So hopefully you can see all those little dots there. Now we're going to count up. See, now we got 8 and 8. So they're both satisfied. But how many total electrons are we using? We got 2, 4, 6, 8, 10, 12, 14. So we got 14. And I want you to do a check and draw that arrow and write the same, or whether it's short 2 or short 4 or whatever it is. But you want to check it. So here we got 14, and that's good. That's how many we had. And they each have 8. So they're all satisfied. Now our final version of how we write this will be chlorine, and there's a single bond here. A single bond has 2 electrons. A double bond has 4 electrons. And a triple bond, I bet you know how many that will have. 6 electrons. So here, so every 2 electrons is a single bond. So we have single bond here, and when we have that, we can draw a line like that to represent the 2 dots with the 2 electrons, making it easier on the eyes. And then we can go ahead and put the rest of the electrons here, like that. And that's our final way that we're going to make this. Let's see if I can just scoot this up some. Yeah, that's probably a little bit better. Alright, so this is your final outcome right here for chlorine gas. Let's do another one. Hydrogen bromide, HBr. So it's not going to be so hard. So we're going to put H, that's equal to 1 valence electron times 1 atom is equal to 1 electron it brings to the party. And bromine's in group 17 again, so it's got 7 outer electrons times 1 atom is equal to 7, and they total up to 8 electrons. Remember, E with a line over it means electrons. So again, we only have 2 atoms, so we can only put them side by side. So we have an H and the Br side by side. Remember, hydrogen only wants 2 electrons, and it's always going to be sharing electrons. You'll never see hydrogen with dots on the outside or electrons on the outside for the purposes of Lewis structures. And we're going to give bromine 8 because that's what it wants. Okay, and so hydrogen here has got 2 electrons, while bromine has got 8. So they're both satisfied. But you don't do this on every single one about drawing the circles. So let's go back to what we had here, because some students would just keep drawing the circles, and I understand it's just to show you. Okay, now on our final form, any shared electrons have to be, you have to put a line for 2 dots or 2 electrons. So we have H and a line to Br. So that's 2 electrons for bromine and also 2 electrons for hydrogen. So we're going to put the rest of these electrons around bromine. So now bromine's got 2, 4, 6, 8. So bromine is satisfied, and hydrogen has 2, and it's satisfied. And that's our final format right there. So that's not that hard, I hope. And let's look at another one, our friendly methane gas that we really could not live without. So again, we're going to put our carbon, and it's equal to, it's in group 14, so it's 4 valence electrons times 1 atom is equal to 4 total. Hydrogen, group 1 again, is 1 valence electron, but we have 4 of these atoms, equals 4. So again, we're totaling up to 8 electrons that we can have to put around these 5 atoms. So carbon loves the middle, so carbon's going to hit the middle. And then we're going to put hydrogen around it. Like that. There we go. I can bend that little part of the dot camera. And we know that hydrogen can only have 2 electrons. So we put these electrons right here. And then carbon's got 2, 4, 6, 8. So it's satisfied. So all these elements or atoms are satisfied. So our final look here is going to be carbon with a single bond to all these hydrogens. Like that. Voila. This is easy so far. Now it does get harder. Now these are Lewis structures with single bonds. Let's do another 3. So we can look at, let's say, iodomethane, CH3I. Well, let's add up all the electrons that they bring to the party. So carbon is going to have 4 electrons in group 14 times 1 atom, because there's no number there, is equal to 4. Now hydrogen is in group 1, so it's got 1 valence electron, but there are 3 of them. Okay, let's see if we can get this to, well, that's pretty well focused. And so times this by 3 is equal to 3. Iodine is group 17, is equal to 7, times 1 atom is equal to 7. Add them up, 14 electrons. Now we know that carbon loves the middle, so we're going to try out with carbon in the middle, and hydrogen loves carbon and a lot of other elements. So we'll put hydrogen around it, and then we'll put iodine right out here. So we're going to give hydrogen 2 electrons each, because that'll all be all that it can hold. And then carbon wants 8. So now we've put 2 on that side, right, left, up, and down. And iodine also goes by the octet rule, so let's make sure it has 8. Now we don't know if this works yet, so we got to check the electrons. But anyway, hydrogen's got 2, 2, and 2. Carbon's got 8. It's good. Iodine's got 8. Let's count them up. 2, 4, 6, 8, 10, 12, 14. Write 14 electrons here. Draw your arrow and write the same. Okay. And let's put it in our final format here. So we have carbon with a single bond to hydrogen, hydrogen, and hydrogen, and iodine. But these unshared pairs, you have to put the dots out just like this to show them. Like that. And that'll be the final form of this compound, CH3I. Okay, let's do ammonia. Ammonia is NH3. Now I bet you guys can add up these electrons. You can pause this video and then add them up, see if you get the right number. So go ahead and pause. Okay, hopefully you're back, and we got nitrogen is equal to 5 valence electrons, group 15, times by 1 atom, because there's no subscript there, is equal to 5. Hydrogen, again, is equal to 1 valence electron times 3. 3. Look at that, adds up to 8 again. Well, hydrogen never goes in the middle because it can't go in the middle. So that only leaves nitrogen. And let's put hydrogen on 3 sides because that's all that we have. And hydrogen can only have 2 electrons. So let's give those to hydrogen right off the bat. And then we've got nitrogen. It's going to want 8 electrons. So 2, 4, 6. Put those 2 right here as an unshared pair. Like that. And then let's put it in our final form. N, single bond to hydrogen, to hydrogen, to hydrogen. And you got to show these unshared pairs of electrons like that. Now, it doesn't have to be just like that. You could rotate the molecule and you could have it like this. They're the same thing, you're just rotating it. Or you could have the unshared pairs on top or on the bottom. They're all the same molecule. And the last one we'll do for these single bonds with Lewis structures will be hydrogen sulfide. H2S. So we've only got 3 atoms there. Let's see what they bring to the party. Hydrogen we know. 2 is equal to 2. Sulfur. Well, that's group 16, I believe. So you guys should have a periodic table. And I'm not going to the periodic table every time to show you on the screen, so you have to keep it with you and look at that. So sulfur's in group 16, so it's got 6 valence electrons times 1 atom here is equal to 6. That's 8. Okay, and by the way, this was 8 electrons. So that's the same. So now, we know hydrogen's not going in the middle, so we're going to put sulfur in the middle and hydrogen on the sides like this. Now, you can put it like this if you want. It really doesn't matter to me. So we know hydrogens get 2 each, and sulfur's going to want to have 8, like that. So 2, 4, 6, 8 for sulfur, and hydrogen has got 2 each, and that's what it wants. Okay, and if you had drawn it likewise this way, for me that would be fine. Anyway, your final form. Or you could have put it like this for me. And on a multiple choice test, you're looking for one of these guys. But anyway, there you go. And 8 electrons and 2, 4, 6, 8. We got 8. And that's the same. Now, why am I putting the same on here all the time? Well, that's because they're not always going to be the same. Sometimes we're going to be short. And then when we're short, we've got to do something extra. Okay? So anyway, this ends the first video on Lewis structures with single bonds. And I'm going to stop it there.